Hello, I'm Daniel Motzer. Today is August 2nd, 2026, and I'm making this for the final exam in ISAS 640 at UMGC. Prior to getting started, if you don't mind coming off mic and introducing yourselves.
Hi, name's Roger McNeese.
Hi, I'm Judy Julian Alexander.
Awesome. Thank you for attending. Thank you for introducing yourselves. We'll get started. Okay, so the purpose of this roundtable is to demonstrate what I have learned over the past 11 weeks in our course. Since this is a discussion and not a briefing, please feel free to jump in with questions at any time. And I will also ask you questions throughout to keep the conversation interactive. In this discussion, I will be covering 4 interconnected topics, which are the role of DSS in decision-making, AI-based DSS technologies, data and knowledge management, and best practices for designing and implementing AI-integrated DSS. On the screen now, I provide high-level insights into each of these topics. I selected these topics because together they represent the core of what I learned in this course, which is that modern information systems, especially DSS, drive meaningful value when they integrate AI, leverage high-quality data, and follow strong design and implementation practices. These topics build on each other, and to illustrate this point, I will tie them together by ending the discussion with American Express's real-world use case of AI-integrated DSS for fraud detection. So diving into the first topic, one of the most important lessons that was reinforced for me in this course is that IT and IS are ultimately tools, meaning their value depends entirely on how they are used. So DSS are tools specifically designed to assist in analyzing data and make evidence-based decisions. While most modern DSS integrate AI, traditional DSS emerged long before AI and were originally large mainframe systems used to solve structured, semi-structured, and operational problems. Over time, DSS evolved to incorporate more advanced analytical capabilities such as data mining, machine learning, and natural language processing. DSS can take several forms, including model-driven systems that rely on mathematical and statistical models, data-driven systems that leverage large data sets to generate insights, and knowledge-driven systems that use expert rules and domain knowledge. Regardless of the type of DSS, their benefits include improved decision quality, increased efficiency, cost savings, and enhanced accuracy. These advantages highlight why DSS remain essential tools for organizations seeking to make informed, timely, and strategic decisions in increasingly complex and interconnected environments. Some examples of modern DSS, which I'm sure you see in your daily life, include Siri, International Business Machines Watson, and Tesla's Autopilot. Moving into topic 2, we're going to talk about artificial intelligence. So AI focuses on creating machines capable of performing tasks that previously required human knowledge and intelligence. These tasks include learning, reasoning, pattern recognition, and decision making. Because DSS are designed to support and enhance decision making, integrating AI into these systems was only a natural evolution. To understand how AI functions inside of a DSS, it is important to talk about machine learning. Machine learning is when we train systems to learn from data and make predictions without being explicitly programmed to do so. Early DSS relied heavily on machine learning techniques such as regression analysis, including linear and logistic regression, classification models such as decision trees, clustering such as k-means clustering to identify hidden patterns, and association rule mining. These early ML techniques provided structured and quantitative decision support and formed the backbone of traditional DSS. As AI advanced, DSS evolved from these simple statistical models, which could predict things such as sales forecasting, into dynamic adaptive systems powered by more sophisticated machine learning techniques, which could make decisions in real time. For example, one of these advanced techniques is neural networks. They are designed to mimic human brain activity, and they enable DSS to detect complex, nonlinear patterns and relationships that traditional regression and decision tree models could not capture. Additionally, with the advent of natural language processing, they expanded DSS capabilities by allowing systems to interpret and respond to human language, enabling chat-based decision support, automated document analysis, and more intuitive user interactions such as sentiment analysis.
Yeah, Danny, a quick question for you. What do you think
Go
is
ahead.
sorry. What do you think is the strongest benefit of AI integration into DSS systems?
So to me, it kind of just goes back to a main benefit of AI. And I think really the biggest benefit of AI to me is the increase in efficiency. Coming from the military, we talk about something called being a force multiplier, like one person doing the job of 5 people. Well, like with AI systems, that one system can do the job of thousands of people around the clock. So to me, the integration of AI into DSS really just drives efficiency. And that's to me, that's the best benefit. But thank you for the question.
All right, thank you.
Okay, moving away from AI, now to the topic. Well, I guess we don't really ever move away from AI because it's in DSS now. But moving on to the third topic, we are going to talk about the role of data and knowledge management in DSS. As I mentioned at the beginning of this discussion, the output of AI integrated DSS will only be as strong as the data has been trained on and the data it receives during operation. Therefore, high quality data is the foundation of reliable decision support, which is why the term data is the new oil exists. Just like machine learning is the umbrella for many AI capabilities, data analytics is the umbrella term for the processes of extracting insights and knowledge from data. Data mining plays a central role in this process by identifying hidden structures and relationships within large data sets, while the analysis of the mined data interprets those findings and translates them into actionable information for decision makers. Modern DSS with AI integration rely heavily on analytics to recommend or automate decision making. Data analytics uses a wide range of statistical, mathematical, and computational techniques to analyze data and uncover patterns, trends, and relationships. There are four primary data analytic techniques to extract value. Descriptive analytics tells an organization what happened. Diagnostic analytics tells an organization why it happened. Predictive analytics tells an organization what might happen next. And prescriptive analytics tells an organization what they should do next. In this course, a main takeaway from me is how the evolution of AI and big data, which I defined on the slide, are enabling DSS to discover hidden patterns from unstructured data to aid in each of the four analytic techniques. As I've highlighted, modern DSS no longer strictly requires structured historical data and predefined models, but now through advanced AI techniques and non-relational databases can interact with data in real time and automate decision making. A form of this real-time analysis is stream analytics, which enables AMX's real-world example I will cover later in the discussion.
Hi, Daniel. I have a question.
Yeah, go ahead.
Out of the four types of data analytics, which are you most interested in?
So of the four, they are all very important, but I think the one that always jumps out the most to me is diagnostic analytics, because that's the one that tells an organization why something happened. I know for me in my workplace, knowing why is one of the most important things, because that then enables us to look back, understand why something happened, and then look forward. But with saying that, I mean, that also kind of shows how important predictive analytics is too, because that tells an organization what could happen in the future. So yeah, I would say diagnostic analytics, because then you understand the why of what happened, and then predictive analytics, because then you can start looking forward, and that can really aid in things like strategic planning. But good question, Judy. Thank you.
Thank you.
Okay, moving on to my fourth topic before I dive into the Amex use case. So in the past three topics, I talked about the vast benefits of DSS when integrated with AI and using data analytics. So at this point, you might be thinking, what's the catch? I heard about all these great benefits. So for each of you, ideally without looking at the screen, what is the catch? Like what can go wrong with implementing AI into DSS?
Well, one of the things I can think about is data being biased or inaccurate. Yeah, and if data is biased or inaccurate, then the results can be unreliable.
Yeah, I agree. Rod, you have anything to add?
Yeah, I would say AI. It depends how the AI, how the learning model works. A lot of times AI will be overly confident with their hallucinations, and it's just making up things. So you definitely need some human oversight on the actual AI decisions, and so I wouldn't overly rely on it until maybe the model gets a little bit better.
Yeah, thank you both. I agree with your answers. Sounds like you guys could be giving this presentation instead of me. But thank you. So we'll jump back into it. So as you both highlighted, the catch is that AI integrated DSS can recommend and automatically execute bad decisions if not designed and implemented correctly, which can lead to serious ethical concerns such as bias. So organizations need to ensure they follow best practices. Best practices for designing and implementing AI and DSS include planning and designing, data collection and pre-processing, evolution and testing, and deployment and maintenance, as shown on the screen. What was interesting is that in this course, I realized that for organizations to continuously develop and use AI integrated DSS effectively, they need to integrate those best practices into a repeatable strategy to ensure their systems and usage are ethical and not unethical. But luckily for organizations, I really was able to put this together in this class and think NIST, SSDF, and AI RMF's 4 functions and phases perfectly incorporate the best practices we learned and are repeatable strategies organizations can use, as I will highlight in the next example with Amex. But for each of you, I'm going to challenge you with the question again. So looking at those best practices, phases, and functions, just one of you can answer. Which do you think is the most important?
Let me see. Governance, I would say is the most important because from an IT leadership perspective, someone needs to be accountable for how the system is used.
That's actually my answer too. I agree with you. Yeah. So
Yeah, I was going to say the same thing. Yeah, somebody
yeah,
needs to be accountable for what's going on.
right. And I mean, SSDF literally calls that phase prepare the organization. So it just sets the organization up for success by having someone accountable for what's going to go on. So yeah, it sounds like we all just took the same course for the last 12 weeks, I guess. All right, moving on to my real world case study to tie the entire presentation together. So looking at this case study, it provides a strong real world example of how AI integrated DSS can transform organizational decision making. So as a global leader in banking and financial transactions in the 2000s, Amex faced increasing rates of credit card fraud, which created both financial risk and customer dissatisfaction. To address this challenge, the company integrated advanced AI techniques into its DSS to automate and expedite fraud detection. Amex adopted a supervised learning approach using deep learning models, including generative adversarial networks and recurrent neural networks, which we talked about earlier, to identify and prevent fraudulent transactions in real time via stream analytics, which we also talked about under data analytics. So these models were trained on extensive internal data, allowing the system to learn the difference between legitimate and fraudulent behavior based on real world patterns. So Amex's implementation was successful, and I think it's because they followed several of the best practices that we just talked about. For example, during the planning and design phase, the company clearly defined the problem and brought in specialized AI talent to develop an effective solution and reduce resistance to change. For data collection and pre-processing, Amex removed the chance for bias by using its own transaction data to train the system. This ensured that the training data closely mirrored the operational environment the system would encounter. Additionally, the evolution and testing phase was extensive as Amex trained and refined the model over a 5-year period, testing it in controlled groups while traditional fraud detection methods not leveraging AI remained active. Once deployed, the system incorporated safety mechanisms that allowed customers to report false positives, ensuring they were not negatively affected and enabling the model to continue learning and improving from the customers using it, which keeps the human in the loop. This ensured there was still human oversight in case system errors did present themselves. By mitigating the pitfalls of data quality issues, bias, and a lack of human judgment, the impact of this AI integrated DSS was significant. For example, in 2020, Amex achieved the lowest rates of credit card fraud in the banking industry, demonstrating how a well-designed AI system can enhance security, improve the customer experience, and strengthen organizational performance. So moving on to my conclusion, I just want to talk about how prior to the advent of information technology, companies managed their organizational data by hand on paper, which sounds crazy in modern times. But through IT, IS, and AI, they improved efficiency and accuracy across various tasks, but it's important to remember they are just simply tools. And if they can be used accurately, as Daily 2026 highlights, high volume, multi-source, and diverse data, when paired with explainable AI models, can enable DSS to operate effectively in real-world complexity and uncertainty. This exact benefit I just demonstrated with Amex and their ability to identify fraud detection problems with AI integrated DSS, conducting stream analytics, which can make millions of decisions concurrently in real time. As I continue my career in managing information systems, I will ensure that all AI integrated DSS I operate are designed to solve a specific problem and utilize the best practices discussed to mitigate pitfalls while reaping the benefits. So we are currently at about the 15-minute mark. I'm going to ask you both just one question, and then we will wrap up. So over to you, Judy. What's your main takeaway from this presentation?
I think for me, what I kept hearing over and over again consistently is that human judgment still needs to be a part of the decision-making process.
Yeah, I agree. I mean, it would be great if AI could just automate every task without the need for human oversight, because then that efficiency benefit I talked about could be even greater. But I just don't think we're there yet. Even with Amex, I mean, it is executing decisions in real time on its own, but humans are still in the loop with the ability to say, hey, you know, that transaction actually wasn't fraudulent. So yeah, I agree. At this time with AI integrated DSS, we definitely need human oversight. Well, over to you, Roger. What was your main takeaway from this presentation?
I would say I appreciate the way you had a practical application with Amex, where you have a vast amount of data, and the AI and decision support systems can actually look for patterns of fraud and waste and abuse. So that shows a good real world application of the technology.
Yeah, I agree. I mean, I have Amex cards. So when I first read that case study, I was like, oh, wow, okay, that's everything that's happening behind the scenes when I make purchases. So I've always found that one to be a really interesting example.
Unless they cancel your card while you're on vacation.
Yeah, that ideally their AI system learns your patterns and doesn't make mistakes for non-fraudulent activities. But people are getting paid a lot of money at Amex to make that happen. Okay, this is my references slide. They're all the references I used to make this presentation, and that concludes the discussion. Thank you for attending.
Thank you, Dan.
Thank you.